It seems like my friends at Elector liked my previous video. After I finished their Nixie display clock, they started sending me their magazines, which I hadn't received in years. Happy to say that those are still fantastic. They are full of DIY projects for all skill levels, and articles that appeal to embedded, high frequency, and test gear people alike. Check out the link in the description for a free, self-terminating 4-month subscription. That'll include actual paper magazines and unlimited access to the Elector archives dating back all the way to 1990. Can't guarantee though that they won't embarrass you by sending one of their new business issues as well. I was offended to find a business pamphlet in my electronic engineering postbox. But they made up for it by sending another awesome kit. It belongs to the same category as the Nixie clock. Everybody has one on their bucket list, but it's never the first item. Because it doesn't make you more productive. It doesn't mine cryptocurrencies. And you can't teach it any new tricks. A Tesla coil is a matter of prestige. A highly effective one. But before demonstrating your immortality to people, the transformer has to be assembled. The manual starts elsewhere, but I think it would make sense to start varnishing the secondary coil first. A slowly rotating motor ensures that this beauty receives the uniform coating that it deserves. The secondary coil is a PVC pipe with a few thousand windings of fragile magnet wire. Instead of spray paint or polyurethane, I'm going to go with a low viscosity epoxy resin. After a single application, that'll form a thick, crystal clear layer that protects against mechanical stress and arcing. Air bubbles can be popped with a mini blowtorch. But don't overdo it, this is not a spit roast. While that's curing, we can tend to the electronics. These parts will become a remote control that can trigger the actual Tesla transformer. 5% carbon film resistors are unexpected and unacceptable in such a pricey kit. But they are standard values, so I can rectify that. The designers have decided to use non-standard footprints for their 5% carbon film resistors. So the ever-popular Biegelehre cannot be used this time. In general, properly mounted resistors seem to be a low priority here. These guys are just mounted vertically for no good reason. Who knows, maybe their PCB design software acted up. The presence of an SD card slot and a MIDI input bode well for some advanced functionality. But neither SD card nor these weird batteries are included in the kit. I don't see why they didn't use a standard 9V block instead of these rare CR123A cells. I was just about to complain about a missing capacitor, but at least in that regard they are innocent. They are 1 Tesla, and this kit is a result of a successfully funded Kickstarter campaign 5 years ago. It may not be good practice to solder everything at once. Maybe I can make up for it though with a proper best practice fume extractor. That has been a huge improvement to my soldering game. Look, no more smog in the air. Visibility is almost a few meters now. In spite of a few minor problems, I'm still willing to make this thing look as good as possible. The board will be visible prominently in an acrylic enclosure after all. May the vertical resistors and the errors on the silk screen never be forgotten. No rubber feet are supplied, so the remote has to stand crookedly on one edge and 2 of the display screws. Now to the much more important main device. The high voltage driver board will not be visible later, so it doesn't matter how it looks. Thought the guys at 1 Tesla and proceeded to squeeze it into a bag with another board. During shipping that caused some superficial scratching on the glossy black finish. They have supplied some very good quality Cornell Dubilier electrolytic caps. A good choice because these will store rectified mains voltage later. as much as I enjoy making fun of their design choices, like this oversized resistor. I'd like to take a moment to appreciate their clever schematic. The kit itself doesn't encourage learning or understanding at all. It's a purely mechanical step-by-step assembly guide. This is a current transformer that sits over here. With the aid of some signal processing, it turns current pulses to the coil into voltage pulses over here. The two UCC parts are inverted gate drivers. Via a gate drive transformer, they operate the two IGBTs. The transient voltage suppressors are not important and have not been delivered. The 1000 microfarad caps are charged with mains voltage. The IGBTs are used to alternatingly push and pull the charges into or out of the primary coil. Thanks to the current transformer feedback that happens at exactly the resonant frequency of the system. And via opto-isolator input, the remote control can turn the whole show on and off at audio frequencies. That's a minimalistic universal circuit. I like it. Because there is no need for an adjustable spark gap or a commutator motor, a driver like this will often be called easy mode or a solid state, depending on whom you're talking to. The infamous CDE caps are mounted right next to the mains fuse and the bridge rectifier. This is the current sensor. It's a real through-hole component. There is actually only one SMD component in the kit, the SD card slot, and they have pre-soldered that for you. Most of the pads are thermally relieved, making the remaining assembly super easy. Now, before installing the power transistors, it's a good opportunity to perform a quick smoke test. For that, we'll hook up the remote control with the supplied optical fiber. We know better than calling this thing an optical fiber, don't we? This is just a plastic string with no known core diameter or numeric aperture, but it serves its purpose and audibly operates the gate drive transformer. That way we can move on safely to the next step and sandwich the LGBTs between the heatsink and the mainboard. Here's a hint from the future. These have a tendency to arc over to the heatsink, so I would recommend choosing a better thermal interface material or transistors without exposed metal tabs. Also, you've got to add some spring washers to the M3 standoffs which they are using as electronic interboard connections. Otherwise they'll come loose and be completely unreliable. The next layer has to be a shield, because there are a few sensitive integrated circuits on the board that want to be protected from the megavolt discharges above. I may not be completely happy with the kit, but just saying megavolt brings back the hype. The primary coil is 7 windings made in double-sided PCB traces. To mount the secondary on it, we have to fabricate 2 plugs from these laser-cut acrylic pieces. The manual doesn't give you a hint on what kind of glue you should use, so I'm going with my intuition. This transparent low-viscosity product will partially dissolve acrylic surfaces. If 2 such surfaces are allowed to cure together, the bond is pretty much indestructible. That's why we can't re-experience the capillary action all that often. So, enjoy. By now the epoxy coating of the gorgeous secondary coil is cured. The ends of the magnet wire get connected to bolts in the acrylic end caps. And since this fragile connection would be a nightmare to repair later, I'm reinforcing it with a permanently elastic glue like B7000. Possible stimulation to skin and eye. Because there's still continuity, I think we are successful. The other side needs a similar end cap, but I don't think that's worth showing. This beautiful moment definitely is. The jumper cable connects the low side of the secondary coil to ground and protective earth. There are no other connections to the secondary. The very high voltages we are about to witness are solely relying on induction. And because the coupling of the two coils is relatively loose, there's not a lot of energy to back up our megavolt. I'm not saying the thing will be safe to touch, but it's not the ultimate death ray either, so we'll have to keep looking. The aluminium donut is called top load. With its large surface area, it acts like a capacitor. And that in turn, combined with a secondary coil, makes an LC oscillator. In spite of a few complaints about the details and the price of this kit, I'm generally impressed with the outcome. It's not that easy to match the resonant frequencies of two LC circuits while using mostly standard components. And it sure isn't that easy to deliver a handy-sized Tesla coil that produces these kind of impressive discharges. Originally, I wanted to connect this to the Elector Formant synthesizer, but that'll be surprisingly difficult because there's no analog audio input yet. At least we can play back a few MIDI files from the SD card. That's it for today. Thank you for watching. And don't forget to check out Elector's free self-terminating trial subscription. All the details are in the description. A megavolt is pretty cool, but I prefer a nanovolt these days.